Good morning, everyone. My name is Lawrence Egareva, and I will be presenting this project on sentiment and emotion analysis, an area of artificial intelligence that explores how machine can detect, interpret, and respond to human emotion expressed through text. In this presentation, I'll walk you through why this topic is very important, the tools and the methods I used, including both traditional NLP techniques like VADA and the modern deep learning models like transformers, and the practical insight again from comparing these tools. Sentiment and emotion analysis is one of the most real-world applicable area of NLP. It is what allows companies to instantly know if a person on Twitter is angry, excited, or disappointed about a new product launch. It's what powers chatbots and visual assistants that they can detect frustration or happiness in a user's message and adjust their tone accordingly. It also helps mental health monitoring by identifying emotional distress, impatience, journeys, or online posts before it gets worse. So our project, or rather this project, demonstrate how computers can move beyond just reading words to understanding feelings, recognizing not just what we say, but how we feel when we say what we say. So by the end of this presentation, you will see how NLP tools are bridging the gap between language, emotion, and technology and making AI system more human-like and empathetic. So my motivation for choosing this topic is because emotion drives nearly every human decisions, from what we buy, eat, watch, where we go to, how we vote, how we interact online. Everything is hinged on our emotion. And in today's digital world, billions of people express feelings every day through tweet, product review, YouTube comment, chat messages, and that is an enormous stream of information, emotional data that companies, government are eager to understand. Even though humans can easily sense tones and emotions in conversation, teaching machine to do the same is extremely difficult. That is the core problem we are. So even though humans can easily sense tone and emotions in conversations, teaching machines to do the same is extremely difficult. That is the core problem we are addressing. How can we make computers to understand emotions from tests as accurately as humans do? When people express emotions, they rarely do it in a straightforward way. For example, someone might tweet, "I just love waiting in traffic." Grammatically, it sounds positive, but the speaker is clearly being sarcastic. A student might post where that exam was something, neutral words, but emotionally, it likely means disappointment or frustration. So, different culture may express the same feeling differently. In some region, not bad means pretty good, while in others, it is truly neutral. So this subtlety confuses sentiment models that relies on words level polarity, positive or negative, rather than context. So there's also the challenge of mixed emotion. A single text can contain both positive and negative tone. For instance, the movie had great acting, but the ending ruined it. A simple model may label this sentence as neutral, even though it expresses admiration and disappointment at the same time. So finally, language evolved quickly. New slangs, emojis, abbreviations appear constantly, especially online. So, so ultimately, the project focusing on addressing these challenges by testing how different NLP tools, from rule-based system like VADA to contextual model like transformer handle sarcasms, cultural nuance, and emotional complexities. The main goal of this project was to apply and compare different NLP tools for sentiment and emotional analysis and to understand how effectively this tool can interpret human emotion in text. Because even though humans can easily sense tones and emotions in conversation, machine does not have the ability, or even training machine to do the same is extremely difficult. And that is a core problem this project is seeking to address. How can we make computers understand emotions from text as accurately as humans do? For example, someone might tweet, I just love waiting in traffic. Now, grammatically, it sounds correct, it sounds positive, but the speaker clearly could be sarcastic, could be just saying something the opposite of what he's actually saying, could be his real intentions. But machine cannot sense that. Or a student might post where that exam was something. That's a neutral word, right? But emotionally, it's likely mean I'm disappointed with the exam or I'm frustrated. So there are different subtlety that confuses sentiment models that relies just on word level polarity rather than on context. So I wanted to find solutions to these basic challenges by answering questions such as, can a simple rule based model like VADA accurately detect positive or negative sentiment in a short informal test such as tweet or customer comment? How does its performance compare to a deep learning model like Transformer, which learns emotion context from massive data set rather than the predefined word list? And finally, what are the strengths, the weakness, and the trade-off of each approach? In doing this, we needed to evaluate how well each NLP tools perform. We needed test samples that truly represent the natural human emotions, the kind people express every day online. And that is why I focus on collecting short informal tests that contain mix of emotion tones, slangs, punctuation, exactly the kind of data sentiment analysis model struggles with. Our data set includes samples of social media posts, customer reviews, and customer survey responses. So once my data set was ready, I needed to I needed to move to the next step, and that was to choose the right tools I will be using for analyzing the sentiment and the emotions. So I exploit three main types of NLP tools, ranging from the simple rule-based system to the advanced deep learning models, to see how their design affect accuracy, context understanding, and speed. And the first one was the test blue. This is a rule-based lexicon model. It's one of the simplest sentiment analysis tool in Python. It uses a predefined dictionary lexicon of words labeled as positive or negative and calculate an overall polarity score from -1 to +1. Secondly was VADA, Variance Aware Dictionary and Sentiment Reasoner. VADA is also lexicon based but it's much smarter in handling social media test styles. It was specifically designed for short informal messages like tweet, YouTube messages, and comment. The third was Transformer, a deep learning contextual model. It is the most advanced tools I use in this project. It is specifically I use the fine-tuned version of it, the Disti Ruby tool, which is available through Hugging Face. Basically, in this project, I use TextBlow as a simple baseline and VADA for a fast social media friendly sentiment detection, and Transformer for deep contextual emotion recognition. So each tools represent a different generation of NLP progress, from static rules to true contextual understanding, allowing me to see how far the sentiment analysis has evolved over the years. After exploring several NLP tools, the VADA, Transformer, and the text block, I decided to focus on VADA for a deeper part of the analysis, and because it offers perfect balance between simplicity, speed, and social media awareness. VADA is lightweight. It runs instantly without needing training data or GPU, yet it is surprisingly effective for short, emotionally expressive tests. It is designed for real-world informal language. It considers and recognizes emojis, punctuation, slangs, capitalization. There's no need for training data, and it's transparent and very easy to interpret. To show VADA in action, I did a live demo. I ran a few examples directly in my Jupyter notebook so that I could visualize how it classifies text and interpret emotional tone. And here is how you can do same step by step. So step one, install the library. Now, if you haven't already installed VADA, open a new Jupyter notebook cell and run hyphen pip install VADA sentiment. Now, this installs the VADA sentiment analysis library from Python's package index. And you only need to do this just once in this environment. Then step two, import the analyzer. Now, once you've installed the library, the next thing is to import the sentiment analyzer class. And in your cell, you just type from VADA sentiment dot VADA sentiment, a little space, import space, sentiment intensity analyzer. Then you create the analyzer object. Analyzer equal sentiment intensity analyzer with a bracket. This object gives you access to VADA's built-in sentiment lexicon and rules for processing text. Then the main step, which is to analyze our sentence, to to feed in a test sample to see how VADA is going to respond. So in our case, my sentence was I'm thrilled about our new product launch with hyphen and an emoji, a rocket emoji. Now you could use any sentence, but just to experiment, so I use this. Now you can see the expected output. VADA has four key values which are outputted in the output section. If you run this code, you're going to see the output as you print it. The first is the neg, which indicates the portion of the text that has negative emotion. Now, in this example, there is no negative emotion in the text. I am thrilled about our new product launch. There's no negative, so it outputs zero point 0.0 as the negative portion of the text. The next is the new. New has 0.65, which is the neutral words in the text. There are neutral words in the text. Then the third is a po, which is the positive portion of the emotions. And in this case, we have 0.35. And lastly, we have the compound class. The compound class is the overall sentiment. So the compound score gives the general normalized value between -1, which is the most negative, and +1, which is the most positive. And in our case, we've got 0.58. So this indicates positivity. Though compared with the transformer, it's pretty weak positivity, but it is very impressive. And I think the VADA model was not able to fully capture the enthusiasm in the word thrill and the exclamation mark and the emoji. But in the overall, it gives a very, very impressive result, knowing that simple based model like VADA can pick up emotional intensity quite effectively. Now, when we consider the transformer is one of the most advanced tools in this project, and generally too. It's one of these it's very impressive tools. Basically, in this live demo, I used the fine-tuned version of the Disti Roberto, which is available through Organ Face. This transformer model goes far beyond word list. They analyze context, meaning they understand how words interact in a sentence. So, like in our sentence here, where we use the word. So basically, the steps in running this is basically the same, basically almost the same, just with few different codes, but basically the same with in the previous slide. So we imputed our test sentence, which is I am so nervous about the exam tomorrow. Now, this is classified as fear with almost 99% score. This is very impressive. Now, unlike the lexicon model, the transformer learn context from massive data sets. They understand that nervous is not just a negative word, which is it, but basically it relates to anxiety, it relates to fear. So this demonstrates the power of contextual embedding in capturing subtle emotional clue. So after testing both Veda and transformer-based models on the same data set, we compare their performance in terms of accuracy, speed, interpretability, and emotional depth. And the finding reveals that each tool has its own strength and trade-off. And which one to use depends on the task, the data set, and the computing resources that are available. Transformer clearly produce more accurate results for nuance or context-dependent sentences. Speed and efficiency, whether it's extremely fast, can analyze thousands of short sentences per second on the CPU, perfect for real-time dashboard, live stream tracking, or survey summaries. Transformers are slower and computationally heavier, especially for long tests or large batches. On CPU, they may take seconds per samples, while GPU is still lower than VADA but far more accurate. This difference highlight a common trade-off in AI speed versus intelligence. Interpretability, VADA outputs, neg, new, pose, and compact are transparent and easy to explain. Anyone can see how the score was computed from known words. Transformer outputs are more like black boxes. They give confidence scores, but not always clear reasons why they classify something as fear or joy. So in sensitive domain like healthcare or law, interpretability becomes crucial. So sometimes simpler is is safer. So the key takeaway, VADA is excellent for lightweight, quick sentiment scoring, ideal for live feedback or business analysis. Transformer are better when context and emotional precision matters, such as customer support, mental health monitoring, social behavior research. Choosing between them depend on your priority, speed versus sophistication, simplicity versus subtlety. One of the biggest challenges in sentiment and emotion analysis is fairness and bias. Now, ensuring that model works equally well across different group and languages and culture is something very, very challenging. So if models are trained on biased data, for example, a model trained mostly on Western English tweet, it might interpret African American vernacular language phrase like that's bad as negative, when in context it can actually mean that's awesome, that's great. Similarly, in some Asian culture, politeness or understatement may express emotional indirectly, e.g., it is okay, I guess. It might really mean strong disappointment, which the model could misclassify as neutral. Another challenge is sarcasm and irony, which can completely reverse meaning. For instance, the sentence great, another Monday meeting, sounds positive, but in actual is negative, or just what I needed. Another software crash is clearly frustration, though every word seems neutral. So models that rely on surface level keywords struggle with this subtle tone. And the third challenge is data imbalance. Some emotions appear far more frequently than others in training data set. For example, data set often contain many examples of joy or sadness, but very few disgust or surprise. So as a result, the model may learn to always predict common emotions and ignore the rare ones. This leads to skewed accuracy, where it looks good overall, but fails on unrepresented classes. So, finally, the challenge uh, um, of training an ethical AI. How do we ensure these models are used responsibly? Addressing all these challenges: fairness, scarcity, imbalance, bias is a key essence of the training. So these applications shows how natural language processing can understand and respond to human emotions, truly bridging the gap between technology and empathy. Sentiment and emotional analysis isn't just an academic exercise. It is already shaping how companies, government, and healthcare organizations make decisions every day. Let's consider, for example, social media and public opinion. One of the most common applications in tracking public moods on platforms like Twitter, Reddit, or YouTube. For example, during an election, analysts can monitor whether public sentiment towards a candidate is trending positive or negative, just like the New York mayor race has just concluded now. Government and NGOs could use emotion tracking devices to understand public anxiety, anger during crisis such as natural disaster or pandemic, just like the shutdown that the country is currently going through. So there's a lot of applications of sentiment analysis in healthcare and mental health. Healthcare, emotion detection, support, mental health monitoring, and patient feedback analysis. Education and e-learning, just to name a few. Emotional aware system are also entering education. Online learning platform can analyze student feedback or discuss posts to detect confusion, boredom, or engagement level. And this help instructors adapt materials or provide personalized encouragement. So in summary, across social media, visual assistance, healthcare, marketing and education, emotional analysis is helping system move from just being reactive to emotional intelligence. Models are becoming more accurate, context aware, and this application will only grow, leading to technologies that can adapt, sense, and empathize with human emotions. Emotion aware AI represents the next frontier of human computer interaction, moving beyond machines that merely process information to a system that can actually sense and respond to emotional context. When you think about it, the goal is no longer just to make computers smart, but to make them emotionally intelligent, capable of understanding why a user is frustrated and when they are excited and how they are feeling. An example, even as we conclude, is a customer interaction. Imagine a customer support chatbot that doesn't just answer questions, but also tries to detect the frustration or the excitement in the user's tone or wording. If a user types, I have tried this 3 times and still not working, a traditional bot would just reply, help, try again. But an emotional aware chatbot will recognize the anger and apologize sincerely. Might even escalate to a human representative or adapt its tone to sound more compassionate. That is the kind of humanized AI experience that we are moving towards. So the future of NLP lies in developing AI that understand both logic and feeling, making technology genuinely responsive to human experiences.